Hey everybody, this is for my grade 10 MIAP students. I'm going to make the answer key for the review and kind of explain things as I go. If you're stuck on any of them when you look at the answer key, you can come over to this video and just even skip to whatever part you're stuck on. And here we go. Alright, you're not being asked to simplify these or solve these, you're just being asked which ones are rational. That's a 7, which is 7 over 1, so rational. That's repeating. So it's for sure going to be a fraction. In fact, it's 7 and 496,352 9,999,999ths, which is a fraction. That's obviously a fraction. That is not a fraction, and it can't be written as one. Neither can this. I had to think about this one, but neither can this. This one can. The cube root of 27 is 3. That's 3 over 4, which is a fraction. That is obviously a fraction. It's 11 over 1. And that is not even a real number. It's an imaginary number, so it's definitely not rational. So there we go. There's number 1. Number 2. Let's do the opposite. Which of these are irrational? Well, obviously this 87 is not a perfect square, so that's irrational. 64 is a perfect cube. It's 4 cubed, so that's rational. The 4th root of 32, you know what? 32 is a perfect 5th root. It's 2 to the 5. It is not a perfect 4th root, so that would be irrational. 18 is not a perfect square, neither is 5. Irrational. Pi is definitely irrational. That is not irrational. It's 7 and 549 9,999ths. No, sorry, just 999ths. Yeah, 549 999ths. Okay, that's a 4th root. 16 is 2 to the power 4. 81 is 3 to the power 4. So that thing would just be 2/3. That is totally a fraction. Oh, sorry. We only want to circle irrationals. That's rational. So rational, rational, definitely rational, and definitely rational. So just those 4 up there that were irrational. Sorry, that's a mistake. Is rational. I'll even put it's cleverly disguised, but it's 2/3. Okay, which ones of these are whole numbers? Okay, my whole numbers are 0. 18 over 2 is 9. The square root of 9 is 3. So this thing is just a cleverly disguised 3, which is a whole number. That's an integer. That's an integer. The first one was an integer. That's rational. This is irrational. This is 4. You're a whole number. You're 3, and pi is not a whole number. So just those 4. Circle the natural numbers. That means numbers we count with. That's irrational. That's a counting number. That's 2. That's a counting number. That's a half. That's not a counting number. The cube root of 8 is 2. I can count with that. 0 is a whole number. It is not a natural number. You don't need 0 to count with. You don't count with negatives. That's 11. That's a counting number. That's not a counting number. And that is not a counting number. So once again, it's 4. Okay. So expect a few questions like that on the test. Simplify the following radicals. Okay, what's the biggest perfect square in 80? I think it's a 16, right? 16 times 5 is 80, so this would be 4 root 5. What's the biggest perfect cube in 56? I think it's 8, so this is 2 cube root of 7. What's the biggest perfect square in 288? I think it's 144, so this is 12 root 2. Okay. The perfect cube in 270 is 27, which is 3 times 3 times 3. So I can take the 27 out. It's now a 3. And I don't know why I made it so small. I'll tell you what, I'll make that the 3. And then there we go. Cube. Oh, that's... Boy, I missed that. That's the index of a 3. So if I took 27 out of 270, that leaves me with a 10. 54 squared root. What's the biggest perfect square in 54? I got to think about that. Is it 9? I guess it is. 9 times 6 is 54. So 3 comes out, because that's what the square root of 9 is, and 6 stays behind. Is that right? I think so. Anyway. Cube root of 520. Okay, I got to think about this. What's the biggest perfect cube in 520? All right, I'll start listing them. Is there an 8 in there? Let's see. 8. You know how you can tell if a number goes into... 8. Do you know how you can tell if a number has 8 go into it? You can, if you divide it by 2 3 times and you still have a whole number, it's divisible by 8. So half of this is 110. There's 1 2. Half of that is 55. No, you couldn't get a third 2 out of there. So it's not an 8. Does 27 go into that number? Really? Blah. How many 27s? Okay, first of all, if 27 is going to go in, that means 3 goes in. And you know what? 3 doesn't go in. 5 plus 2 plus 0 is not a multiple of 3. It's 7. So it's not that either. Okay. Now, it can't be 64 because 8 didn't go in. Let me double check 8. Am I wrong about 8? 520, 110. So there's divided by 2 again. No, 55. It's not an 8. So it's not an 8, it's not a 27, it's not a 64. So that's 2 times 2 times 2, 3 times 3 times 3, 4 times 4 times 4, 5 times 5 times 5 is 125. That's not going to go in there. 6 times 6 times 6, if 3 didn't go in, 6 can't go in. 7 times 7 times 7? What's 7 times 7 times 7? 7 times 7 times 7 is, oh, we just went, I had this on my other one. I think it's 147. What if we times 147 by 5? Will that go in? No, that won't go in. I am honestly stuck here. What the heck? Is this already as simplified as it can get and it's messing with me? How dare it? Because I am completely almost out of options here. So there's 2 cubed, 3 cubed. So let me list them again. It doesn't have an 8. It doesn't have a 27. It doesn't have a 64. That's 2, 3, 4. If it doesn't have an 8, it can't have a 64. It doesn't have a 125. 6 times 6 is 36, and times another is 216. And 216 doubled is 432, and then add another 216. You're past 520. So it's not 216. Okay, so that's 2, 3, 4, 5, 6. 7 cubed is, oh, wait a minute. 7 cubed. 7 times 50. Oh, hang on. I have that wrong. 7 cubed is not 147. 7 cubed is 49 times 7. 50 times 7 would be 350. So 350 less a 7 is 343. Well, that's still not going to work. If I get 2 of those, I'm already past that number. So what is 8? It can't be 8 cubed. So 2, 3, 4, 5, 6, 7. It can't be 8 cubed. You know what? I think that one was messing with us. I don't think that simplifies. Okay, I'm going to cheat now. I do have a calculator that actually does simplify cubes, I think. Do I have it here? Let's see. What is math? The cube root of 520. And yeah, look at that. That's not going to be, that is an irrational number. That is not something that simplifies. So, yep, that one was messing with us. I won't do that to you on the test. That was cruel and unusual punishment. Weird. Doesn't simplify. Very mean of them. Okay, now let's go the other way. Write the following as a mixed radical. That is a mixed radical. We had this problem in the notes. This is a mixed radical. We would like this as an entire radical. That's a mistake. That's a typo. Okay, so 8 goes into the bracket and becomes 8 squared, which is 64. 64 times 5. 65s would be 300, and 4 more 5s would be 20. So I'm thinking it's the square root of 320. Let me just double check that. 64 times 5. 4 5s is to carry the 2. 32. Yep. That's that. There we go. Okay, this one's easier. 3 root 2. So the 3 goes into the bracket, becomes a 9. 2 9s is 18. 6 goes into the bracket, becomes 36. 36 4s, that's 120. Add 24, that's 144. Which makes sense because the square root of 4 is 2 and 2 6s is 12. Haha. So, cool. 7 root 3. The 7 goes in and becomes a 49. 49 3s. Oh, I did this earlier today. 49 3s is 150 less a 3 is 147. And okay, that's a cube now. 4 cubed is 64. 64 tens is 640. And this is a power of 4. 2 to the power of 4 is 16. So this is 16 threes, which is 48. And oh, I lost a half mark if I stop there. What did I forget? Oh yeah, that's a cube root and that's a 4th root. Those are not square roots. If you forget those indexes, I have to assume you think they're square roots and I have to mark you wrong. So make sure you don't do that on the test. Okay, cool. You promise not to do that and forget the indexes, and I promise not to give you ones that don't work. There we go. Number 7. Change this to a fractional exponent. Okay, well this is 19 to the 1/2. This is a to the 4/3. This is y to the 5/3. And this is 8 to the 2/6, which I might as well simplify to 8 to the 1/3, which by the way is actually just 2. The cube root of 8 is 2. But I guess you could stop there and we give you the mark. Write this as a radical. Okay, well this is the square root of 12 cubed. I don't care if you write it this way. If you put the cube around the square root or if you put the cube into the square root, it's the same answer either way. We talked about that in the video. This one you have to actually change to a fraction first. If you have to know that 0.25 is a quarter, so it's the 4th root of 6. This one I would change to the square root of 9, which is 3, and then 3 to the, I don't know why, there's no radical to be had here. Okay, that's what I'm leaving it as. This one I would leave as the 4th root of AB to the power of 5, and again it's the same thing. If you do this time here, you know what, I'm going to write something, just I'll write it on scrap paper here if I can find some scrap paper. Here you go, scrap paper. Do you see why, let me move up a bit, if you wrote this, I'd have to, oh, actually these are wrong. That's, sorry, my bad eyes thought those was a 2. That's a 4. There we go. Okay, if you wrote, let me, why did I write it so far down? Let me do it again. If you wrote this, I have to mark you wrong. Well, what's the difference between this and this? Well, obviously, what is the difference between that and that? It's the bracket. Why does that matter? Well, the bracket up here suggests that A and B are both being taken to this power, but this one is A times B times B times B times B times B. Only the B is getting the power, and that A becomes a coefficient. I know you're thinking, I thought it could only be a coefficient if it was a number, not a variable. Actually, we kind of lied to you back in junior high when we said something like 2x is only a coefficient and a variable. Technically, you can have a situation like, say, 2xy, where I can call y my primary variable, and then this is my variable coefficient, and this is my literal coefficient. I know. Blech. Perhaps just forget I said that. Sometimes the vocabulary of math can be quite tedious. All right, the square root of 81 is 9. Okay, let's see. I think I'm going to deal with the negative first. Then I'm going to, what's easier, squaring 64 than cube rooting it? I don't think so. I'm going to cube root 64. By the way, wait a minute. Why am I cube rooting 64? Why don't I just go 64 divided by 8 is 8? There we go. And I'm going to cube root 8, which is 2. And then 2 squared is 4. I didn't even notice right away that 64 divided by 8 is just 8. That's sad. This is 1 over 36. This is 144 to the 1/2, which is the square root of 144, which is off the page, sorry, which is 12. This is the square root of 100 to the power of 6, which is 10 to the power of 6, which is 1 million. Very nice, because you know that powers of 10, you just, whatever this number is, that's how many zeros there are. You should have learned that trick in junior high. If you didn't know it, you should know it now. That's 1 over the square root of 49, which is 1/7. Cool. People who did the homework are probably finding these pretty easy. Moving right along. Simplify each of the following. All right, this is the hard page. These take some thinking, and even I need to do these in multiple steps. Okay, step 1 is I always like to simplify what's in the bracket first. So 12 divided by 6 is just 2. A squared has nothing to combine with, b cubed has nothing to combine with, and p to the power of 5, that also has nothing to combine with. So really the only thing that simplified was the 12 and the 6 in step 1. Now I'm going to get rid of those negative exponents by turning them into their reciprocals. Now the a squared and the 2 don't move, but the p to the negative 5 becomes a positive 5 in the numerator when you reciprocal it, and the reciprocal of b to the negative 3 would be b to the positive 3 in the denominator. If you're wondering why does that happen, why does b to the negative 3 on top of a fraction do that? Well, because it's like saying 1 over b cubed over 1. How do you divide when you're in fractions? You'd multiply the top by the reciprocal of the bottom, and you get 1 over b cubed. So if it's up here and it's got a negative, it's going to end up down there. The converse is also true. If you have 1 over b to the negative 3 like that, expand that to this. How do you divide by a fraction? You take it and you change it to times the reciprocal. And now the b cubed's on top. So a denominator moves to the numerator. That always is true for the way that negative powers behave. So that's how I was able to just flippity-floppity those guys. But make sure you understand that the 2 and the a squared don't go anywhere. They're not negative powers. Now I'm going to distribute this cube through everything. 2 cubed is 8, a squared cubed is a to the 6, p to the 5 cubed is p to the 15, and b cubed cubed is 9. Okay, these are hard. First, I'm going to deal with simplifying what's inside. So a to the 2, that is an a, right? Yeah, a to the 2, a to the 4 is a to the 6. B to the 3 minus negative 5 is actually b to the 8, and that 3 isn't going anywhere. Now I'm going to deal with the negative, which flips everybody over. And now I'm going to deal with the 3, which makes that 27. 6 times 3 is 18, I think. And 8 times 3 is 24. There we go. And, okay, oh my word. What psychopath put this together? Okay, let's simplify the inside first. 48 divided by 3 is 16. 12 minus 6 is 6. Negative 1 minus 17 is minus 18. And 6 minus negative 2 is 8. There's nothing down there right now. Now I'm going to simplify what's in the brackets further. I'm going to get rid of that negative power. So that's 16a to the 6, b to the 8 over x to the 18. And then I'm going to deal with that negative, which flips everybody over. And now the power of a half means that I'm taking half of all those exponents, which really, but it also means I'm square rooting everything. So half of 18 is 9. The square root of 16 is 4. Half of 6 is 3, and half of 8 is 4. Oops, and I'm off the screen again. Actually, there's no way I can fit that on the screen. Let me back up a little. There we go. I always get people who ask me when they see these, hey, do I have to show all this work? Nope. You know what? If you can go from there to there in one step, good for you. I've been doing this stuff for 30-something years, and I can't do that. But, you know, keep in mind, if you're going to be lazy and not write out your steps and you get wrong answers, you're not going to get part marks for anything because I can't see your work. So it's probably in your best interest to show your work. All right, last one, and oh, they've saved the most fun one for last. All right, let's simplify what's inside. 98 divided by 2 is 49. X to the 0, you can just cancel that. That's 1. But there's still an x to the 8 on the bottom, but it's not going anywhere. Good heavens. Y to the, is that a negative 1/2? Holy crap. Okay, I gotta just move this closer to my eyeballs here. Yeah, it is. Okay, so that's why I'm going to put that y to the negative half is going to end up down there, y to the 1/2. And then z to the 1/4 minus 3/4. Now think about this. 1/4 minus 3/4. Do you get why I'm subtracting them? Because when you're dividing powers, you subtract their exponents. 1/4 minus 3/4 is negative 2/4, which is negative 1/2. So it'd be negative 1/2 on the top, which would make it positive 1/2 on the bottom. And we're taking all of that to the power of a half. Phew. So that means we're square rooting the number, which is 7. We are taking 8 to the power of a half, or 8 times a half, which is 4. And then a half times a half is actually a quarter. And then a half of a half is, again, a quarter. There we go. It doesn't say we want radicals. I could if I wanted to. If the question had said, don't give me fractional exponents, give me radicals, you have to read the instructions carefully. Then I would have wanted this for an answer, actually. And then the 4th root, why don't I combine them? The 4th root of yz. There we go. I don't really care which answer you give me. They're both good to me. And there we go. That's the review. If you can handle this page, like I said, grade 11 exponent laws will not frighten you at all. And then when you hit grade 12, you learn a very fantastic new thing about how to deal with exponents and express them completely differently, called logarithms. And to be able to do the logarithms in grade 12, you have to have these skills. So good luck with the test. If you have any questions about this review and how I did it, message me and we could do a Teams meeting. Talk to you later. Thanks for watching.